SURFCAM provides the user with two different Z-roughing toolpaths, an HSM or high-speed machining toolpath and a classic version. I'd like to share some options with you to help you get the most out of the HSM Z-roughing toolpath. But for those users that may prefer the classic Z-roughing style, this is available by going up to Tools, selecting Options. Going over to where you see it says NC Defaults, you can select Use Classic 3-axis milling. We'll go ahead and we'll cancel out of that for now. Let's go up here to NC 3-axis and select our Z-rough. Let's go ahead and select all of our surfaces and stick with a bottom profile. Now to get that bottom profile, I'm going to right mouse button, go to my mask and select mask number 1. And double click there. Okay, and then I'm going to go ahead and shut that mask off and say that we're done. Now as the tool information tab comes up, you can see it remains basically the same. So we'll go on to our cut control. And one thing you'll notice is we now have the ability to have separate stock to leave between our X, Y, and our Z. And we'll go ahead and leave that to default for now. There's a significant change when it comes to offsets. You now have the ability to select a range of values, allowing maximum flexibility in your toolpath. Now this can be especially useful when you're cutting soft materials like aluminum while retaining the total control that may be required when it comes to cutting harder materials. I'm going to go ahead and adjust my maximum or my minimum Z here. And let's go ahead and produce our toolpath. We can see that it functioned as we'd expect, but it did not approach the part from the outside. So let's make that change, shall we? Let's go over here and let's go to our Operations Manager. Let's right mouse button and say Regen with Original. Let's go here to our Cut Control tab and select this option right here, Detect Core Areas, and redo the toolpath. Okay, now I can see that the tool is entering the part from the outside as we desired in this case. Let's turn it. Here we can see though that it doesn't go all the way to the floor, and if we look closely we can see that it would leave an area of standing material right here. So let's make a change. Let's right mouse button, go to our Operations Manager. Let's do a Regen with Original. Let's go over here to our 3-axis Options tab and select our new Adaptive Step-Down option. Now as a place to start, what we've done is we've set the minimum step down to 1/2 of the overall step down and the last levels to even to 1. Let's go ahead and redo the toolpath. Okay, let's take a look at it here. Well, we see it's quite a change. So you see that it goes all the way to the floor, and it's eliminated this area here would not leave standing material. However, you notice off to the side that it may not cut here as we desire. So let's make a change. Let's adjust the boundary so that it can reach the floor in this area. So to do that, let's go and let's right mouse button, our Operations Manager. This time let's do a Regen and reselect. Select all of our surfaces and stick with our bottom profile. But this time I'm going to choose this boundary right here. Now what this boundary is the radius of the cutter plus the desired amount of stock to leave. So I'm going to right mouse button, select my mask number 2, and select my boundary. And go ahead and let's shut that mask off and say that we're done. Let's go ahead and produce our toolpath. This time though, let's go up here and for the minimum Z, let's keep it away from the floor so it does not go down my vertical walls. I want to keep it above here, so let's select that. Let's add my point amount to remove. We can do that by saying Well, let's say 030, do a little bit of math inside of SURFCAM, and say OK. Alright, well, let's take a look at our path now. We see that it's entering from the outside of the part, that it's reaching to the floor, that it's optimized this area here above so there's no standing material. Let's take a look at how adaptive step-down has changed our path here. We say analyze the distance between this point and this point. We can see that the step is about 421. But if we analyze between here and here, the step is about 350 or so. So it really is optimizing our path. Well, let's take it one notch further, shall we? Let's do a regen with a original here. And this time, let's go over to leads and links. Instead of a full retract, let's select shortest route and say OK and produce that toolpath. Now let's take a look at it. Well, our toolpath has been optimized for the most efficient move. It reaches the floor, is adapted above the part, and makes the shortest moves possible for removing our material.